Hi guys, let's start a new chapter. It's called rectilinear figures. So rectilinear figures are basically figures which are bound by a straight line. So bound by a straight line like the way you see all these diagrams here on this page. Next, a polygon. Polygon is basically a closed plane figure with at least three sides. So at least three sides. This is a figure with three sides, four sides, five sides, six, seven, 8, 9 and 10. Now what are the specific name for these figures? These are triangles. We've been doing them forever. Next, four-sided figures are known as quadrilaterals. We have different kinds of quadrilaterals: rectangle, square, rhombus, trapezium, kite, and many more. With five sides is known as a pentagon. With six sides is known as a hexagon. With seven sides is known as a septagon or a heptagon. With eight sides is known as a octagon. Nine sides is known as a nonagon, N-O-N-A, nonagon, and 10-sided figure is known as a decagon. So these are the basic names of polygons with specific number of sides. Now, one key difference between any of these figures and this figure, what would that be? And this is a 1, 2, 3, 4-sided. Side 1, side 2, side 3, side 4, which means this is basically some form of a quadrilateral. But what is the main difference between this quadrilateral and this quadrilateral? Well, the main key difference in this case is there is one angle which is more than 180 degree, and in this all angles are less than 180 degree, right? So all angles here are less than 180 degree. So this is one angle is more than 180 degree. This could be one or more. So at least one angle is more than 180 degree. Any such polygon is known as a concave polygon. And the type of polygon that we've talked about till now, these are basically convex polygons. In this, no angle is more than 180 degree. In this, at least one angle is more than 180 degree. These are known as concave polygons. This is the angle that I am referring to here, which is a reflex angle of angle A. Whichever way you look at it, this is more than 180 degree. Now, in case people refer to a polygon, they are always referring to a convex polygon. Unless specified, all polygons basically mean convex polygon. Let's look at the next slide. So here, let's talk about something which we've done in class 8 as well. What is the sum of all interior angles of a polygon? Well, we know in this case it is 180 degree. In this case, it is 360 degree, right? What is the sum of all angles of a pentagon? I hope you remember the formula. The formula for sum of all interior angles is n minus 2 into 180 degree, or some people also write this as, instead of 180, they write this as 90, which means they take 2 common, which means this is 2n minus 4 into 90 degree, which is nothing but n minus 2 into 180 degree. This is the sum of all interior angles of a polygon. What is n? N is where n is number of sides. So n is equal to number of sides. So in this case, if n is 3, so for triangles, sum of all angles will be 3 minus 2 into 180, which is 1 into 180, which is 180 degree. In this case, it will be 4 minus 2 into 180 degree, which is 2 into 180 degree, which is 360 degree, which we already know. In case of a pentagon, 5-sided, n is 5, so 5 minus 2 into 180 degree, which is 3 into 180 degree, which is 540 degree. I hope this is clear to you. One of the most important formula for this chapter is n minus 2 into 180 or 2n minus 4 into 90, whichever way you want to remember. Again, I would want to clarify one more thing, or like highlight one more thing. A polygon which has three sides has how many internal angles? 1, 2 and 3. So number of interior angle is equal to number of sides. This has 4 sides. 1, 2, 3, 4. How many interior angles? 1, 2, 3 and 4. Next, this has 5 sides. How many interior angles? 1, 1, 2, 3, 4 and 5. So I hope this is clear to you. Number of sides is equal to number of angles in a polygon. Now that brings me to the next thing, sum of all exterior angle. Now what is an exterior angle? So exterior angle basically means if you extend one side of a polygon, which means let's extend this side of the polygon. Let me extend this. The angle formed between the extended arm and the side of a polygon is known as an exterior angle. So this is exterior angle. Now they say that sum of all exterior angles. So how many exterior angles can be there? Let's look at this diagram. If I extend it like this, this is my, let's change color. So this is exterior angle 1. If I extend it like this, then this is exterior angle 2. If I extend it like this, then this is exterior angle 3. If I extend this like this, then this is exterior angle 4. If I extend this side, this is my exterior angle 5, and if I extend this side, this is exterior angle 6. So we are looking at 6 exterior angles. But when they talk about sum of all exterior angles, we are talking about taken in order. So what does taken in order mean? So let's look at this. Let's start from specific point. Let's say, let me give this some names: A, B, C, D and E. Start from whichever point and go either in clockwise or anti-clockwise. So let me go in anti-clockwise direction. So if I start from here, I will extend this. This is my exterior angle 1. Here when I reach, I go along this side. I extend this. This is my exterior angle 2. Right? Then I move in this direction. I extend this. This is exterior angle 3. Then I move in this direction. I extend this. This is exterior angle 4. And I move in this direction. I extend this. This is exterior angle 5. So there are 5 exterior angles if you take it in order. The sum of all exterior angles of a polygon taken in order is equal to 360 degrees. The second most important formula for this chapter, we will use this a lot. Sum of all exterior angles in a polygon taken in order is 360 degrees. Let's take an example. Let's take a simple example that we are aware of. Let's talk about this. Let's say this is an equilateral triangle. This is 60 degree, this is 60 degree, and this is also 60 degree. Now let's take one point. Let's start with A, B and C. So let's move from A to B and take this as the exterior angle. What will be this angle? So since 60 degree and this angle make a linear pair, this angle will be 120 degree. Done. Let's move from B to C and extend BC. So this angle is now my second exterior angle. Again, since 60 degree and this angle make a linear pair, this angle will be 120 degree. Now let me move from C to A, and now let me extend CA. So this is my third exterior angle. Again, because of linear pair, this will be 120 degree. So for this, the sum of 3 exterior angle is 120 degree plus 120 degree plus 120 degree, which is equal to 360 degree. So sum of all exterior angle of a polygon taken in order is always 360 degree. Let's look at one more example. This time let's take a square. Okay, so this angle is 90, this is 90, this is 90 and this is 90. Both these examples are moved in anti-clockwise, so this time let me move clockwise. So this is A, B, C and D. I start from A and move to B. I extend this here. This is exterior angle 1, which is 90 degree, again because of linear pair. Next, I move here from B to C. I extend it here. This is my exterior angle 2 and this is also 90 degree. So this is my exterior angle 2. From C, I move to D. and I extend this here, this is my third exterior angle, again 90 degree. And from D, I move to A and I extend DA. This is my fourth exterior angle, again 90 degree. So how many exterior angles? 4 exterior angle, and sum of 4 exterior angle in this case is 90, 90, 90 and 90, 360 degree. I'm giving you examples where all angles are equal. Well, in case I take a isosceles triangle or a scalene triangle, the angles will be different. So sum of all exterior angle is 360 degree. Sum of all interior angle is given by the formula n minus 2 into 180 degree. Next, sum of an exterior angle and an interior angle. So let's look at any one pair. So this is an exterior angle and this is interior angle. What is the sum of an exterior angle with this interior angle? Yes, it is always 180 degree because it forms a linear pair. In this example, let's say look at the pentagon. So if this is a pentagon, let's say this is 100 degree, how much will this angle be? The exterior angle. Yes, it will be 80 degree because this is a linear pair. So sum of an exterior angle plus interior angle is always equal to 180 degree. That brings me to the next part. What is a regular polygon? Now, regular polygon is a polygon which has all sides equal and all angles are equal. So all sides are equal and all angles are equal. So can you give me an example of a regular three-sided polygon? Three-sided, which means a triangle. Yes, equilateral triangle is a regular polygon. A four-sided polygon which is regular. Yes, a square will be a four-sided regular polygon. Now, so now let's calculate what will be the measure of each interior angle. So let's look at for a triangle. Sum of three angles is equal to 180 degree. Therefore, measure of one angle will be equal to 180 degree upon 3. Why? This is pure unitary method because all angles are equal. Now let's apply this to a standard formula. Each interior angle, so 180 degree is the sum of all interior angle. In this case, n minus 2 into 180 degree. And what is 3? 3 is basically the n in case of triangle. So this is n. So this will be measure of each interior angle of a regular polygon is n minus 2 into 180 degree upon n. And what is the measure of each exterior angle? Well, sum of, let's say quadrilateral 4 angles. So sum of 4 exterior angle is equal to 360 degree. Therefore, each exterior angle will be equal to 360 degree upon 4. Similarly, 360 degree remains 360 degree because sum of all exterior angles will always be 360 degree upon n. So this is another formula that we have, which is measure of each exterior angle is 360 degree upon n. Measure of each interior angle is n minus 2 into 180, which is sum of all angles divided by n. Perfect. Let's look at some questions then. Let's look at question number 1. Question number 1 says, sum of interior angle of a polygon is 4 times the sum of exterior angle. Find number of sides. So let's form an equation. It says sum of exterior angle. So sum of interior angle is equal to 4 times sum of exterior angle. That's the equation, right? Sum of 4 interior angle is equal to 4 times the sum of exterior angle. So let's replace values and let's see what we can get. I know that sum of all exterior angles is always equal to 360 degree, right? Whenever they say exterior angle, it is assumed that it is being taken in order. And what is the sum of interior angle? It is always n into, not n into, it is n minus 2 into 180. 1 second. So n minus 2 into 180 degree. That's the sum of all interior angle. Some people also write this as 2n minus 4 into 90 degree. So let's open this bracket and see how this looks. So this is 180n minus 360 degree is equal to 4 into 360 degree, which is 1200, 1440. That's 1440 degree. 1200, 1440. Perfect. Which means 180n is equal to 1440 degree plus 360 degree, which means 180n is equal to 1700 and 1800. So that's 1800 degree. Therefore, n is equal to 1800 upon 180, which is equal to 10. So say find number of sides. Therefore, number of sides is equal to is 10. That's my final answer. Let's look at this question again. What they have given is an equation which we've created. It says sum of interior angle is equal to 4 times sum of exterior angle. I just replaced it with the formula that I know. Sum of all interior angle is n minus 2 into 180, and sum of all exterior angle is always 360 degrees. Perfect. Let's look at question number 2. Question 2 says angles of a pentagon are in the ratio 4, 8, 6, 4, 5. Find each angle. So let the angles be 4x, 8x, 6x, 4x and 5x. So these are 5 angles. Let's find the sum of all interior angles of a pentagon first. That will be equal to n minus 2 into 180 degree. In this case 5 minus 2 into 180 degree, which is 540 degree. So the sum of all these angles is equal to 540 degree. That's the equation. 4x plus 8x plus 6x plus 4x plus 5x is equal to 540 degree. That's 12, 18, 22, 27. So 27x is equal to 540 degree, which means x is equal to 540 degree upon 27. That's 1 and 2. That's 20 degree. Therefore, angle 1 is equal to 4x, which is equal to 4 into 20 degree, which is equal to 80 degree. Angle 2 is equal to 8x, which is 8 into 20, that's 160 degree. Angle 3 is equal to 6x, which is 6 into 20, which is 120 degree. Angle 4 is equal to 4x, which is 4 into 20, that's 80 degree. And angle 5 is equal to 5x, which is 5 into 20, that's 100 degree. Perfect. So what we did was, first we figured out the sum of all interior angles of a pentagon, which is 540, and the sum of all these angles is equal to 540. That's how we were able to calculate the measure of each angle. Thank you so much. Take care. Be safe. I'll see you with the next video. No homework questions for this one. Bye bye.